Okay, hello everybody. So today we will continue our discussion in Chapter 5, but we are moving into Section 3. And what Section 3 is it introduces some more useful properties of logarithms. So let's take a look here. The first property that I want to introduce you to is what is called the change of base formula. And what this formula allows us to do is evaluate logarithms of various bases. So if you recall on your calculator, whether it be your graphing calculator or your scientific calculator, you have a log key, and that log key is just written as log. Now, if there is no base listed, which there isn't on your calculator buttons, then it is assumed to be base 10. Now, that's fine, but a lot of times we will have logs that have other bases other than 10. So we need a way to be able to evaluate those logs. Let's say if we have log base 2, how would we evaluate that? Well, what we use is something called the change of base formula. And what the change of base formula allows us to do is to change a log into any base that we want. And you can see it right here. So if I have log base A of x, I can change that into log base b of x divided by log base b of a. Now that one might seem a little bit complicated, and to be honest, we probably won't use that one all that much. The one that we will be using a lot of is this base 10 one, and or the base e. And the reason why we'll be using those two more is because the calculator buttons are either base 10 or base e for log and then natural log. And so what you can see here is we have log base a of x. And what you can do to evaluate that is you take log of x and then you divide it by log of a, the base. The natural log is just log base e, so it applies to this as well. You can take log base a of x, and you can say natural log of x divided by natural log of a, and that is also true. So one way to look at the change of base formula is that logarithms with base a are constant multiples of logarithms with base b, and the constant multiplier is 1 over log base b of a. So let me show you an example of how to use this and to evaluate a logarithm using our calculator. So you can see in this particular problem, I have log base 4 of 25. And so what we'll do is we'll rewrite this as log of 25 divided by log of 4. And this allows us now to evaluate this on our calculator. So we will simply take log, and we'll do 25, close out your parentheses, then hit divided by, and once again, log of 4. So you can see this changed this into log base 10 for both of those. And again, the reason why we needed base 10 is that is what our button on our calculator is. It's base 10. So once we have log of 25 divided by log of 4 typed in, we can hit enter and we can get our answer, which is 2.32. And there's your solution. So that means log base 4 of 25 is 2.32. Now, here's another example using the same concept, the change of base formula. It's actually the exact same problem. But what I want you to see here is rather than changing it into log, which is log base 10, we are changing it into natural log, which is simply log base e. It doesn't matter what you change the base to. Conveniently for us, we're using base 10 or base e because those are the two buttons on our calculator. So if I would, in my calculator, type natural log of 25, close out your parentheses, hit divided by, and then another natural log of 4, just like that, hit enter, you can see we get the exact same answer, which is 2.32. So it doesn't matter which log button we use. Now, we have some more properties of logarithms that we need to discuss. So you saw that I gave you what is called the change of base formula. And now we have a few more properties here that will allow us to either expand or condense logarithmic expressions depending on what the problem is asking us to do. So we have three here. The first one is called the product property. And what it says is, if you're logging a product, you can take the two things that are being multiplied together and log them individually and add the answer that you get from each individual log up, and it will be the same. Now, it also holds true in the opposite way. If you're logging something and then you're logging something else after it, like this, you can put those two somethings together and log a product of those two things. So that allows us to either expand or condense an expression. The next one goes right along with the product property. It's called the quotient property. And in this one, if you're logging a division, something where two things are being divided, you can split them up with a subtraction sign. So you can do log of the numerator minus log of the denominator. So we have the product property, we have the quotient property. The last property we're going to talk about is the power property. And this one is extremely useful. What it allows us to do is, if you're logging a base and a power, it allows us to take this power and move it down in front of the log. We bring it down. This is going to be really useful when we have problems. Something like this, if I had log of 2 to the x, this will allow us to bring this variable down and go in front of the log, which will allow us to eventually solve for x. So this is an extremely useful property. It's called the power property. Now, what you see to the right over here is the same rules, just expressed using natural log rather than log. Remember, excuse me, natural log is just log base e. So if the rules apply to logs in general, then a specific base, e or 2 or 7 or whatever it is, also the rules also apply to those bases. So we want to write each logarithm in terms of natural log of 2 and natural log of 3. So this is just really an exercise using the rules that I just showed you. So the first one, we want to break that 6 up into 2 times 3. So we're going to do natural log of 2 times 3, like that. Now, because this is a product, we are going to use the product property and split these two up. So we are going natural log of 2 plus the natural log of 3. And there's our solution, just like that. Now, the next one is a quotient, and it's going to take a little bit more work, but you'll see how this works. The first thing we will do is to break up that quotient. So it says natural log of 2 minus the natural log of 27. Once we have the natural log of 27 written, we can see that that does not fit into having 2's and 3's. So we need to rewrite 27. And what hopefully you realize is 27 is 3 to the third power. So rewrite this again as natural log of 2 minus the natural log of 3 to the third. And now the last property we will use is our power property, which allows us to take this power and bring it down in front of the natural log. So when doing that, we get natural log of 2 minus 3 natural log of 3. And there is your final answer. So again, this is using the properties. In this case, we're expanding these expressions. Now, the next one we are going to do is another sort of kind of examples of what we did in the last example. We're going to use the properties, but this is a little different. We are going to find the exact value without using a calculator. So this is where your knowledge of the log rules will help us to do this. So looking at this first one, here's a helpful hint. Anytime you have square roots, cube roots, things like that, you always want to rewrite them as exponents. That's the first helpful hint with these logarithmic expressions. So in this case, we have the cube root of 5. The cube root of 5, that power, cube root, would be the power of 1/3. So I will rewrite this as log base 5 of 5 to the 1/3 power. Remember, cube root is 1/3 power. Square root, that's the 1/2 power. The fourth root, that is the 1/4 power. So on. Now, the next property we're going to use is the power property, which allows us to bring down an exponent in front of anything that's being logged. So when I do that, I get 1/3 times log base 5 of 5. Now, the last property is an older property that we had in a previous video that said that if the base of the log is the same as the number that is being logged, then they will turn into 1. So this whole part right here just turns into 1. So we're left with 1/3 times 1, which is 1/3. So there's your solution to the first one. It's just 1/3. Now, the next, what you see here are just the work that I just explained. So we don't need to do those. Now, here's another one. It says find the exact value. And similar to the last problem, we're going to not use a calculator. We're going to use our log properties. So let's start out by writing the expression. We have natural log of e to the 6th minus natural log of e to the 2nd. Okay. And now we will utilize the power property and bring both of these powers down in front of the natural log. So we will have 6 natural log of e minus 2 natural log of e. And now what you have to recognize is that we have natural log of e. Natural log of e is simply log base e. So what that's saying is log base e of e. And just like in the last problem, whenever you have the base of the log match the number that is being logged, they just cancel. They turn into 1. So natural log of e turns into 1. Natural log of e also turns into 1. So what this gives me is 6 times 1 minus 2 times 1, which is, of course, 6 minus 2, which gives me 4. There's my final answer. Okay, that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.